Okay, so our next two sessions are on PaaS. So if you're in this PaaS space, these are some of the world's best speakers you can get in this PaaS space. I call them the PaaS cousins. So I'll first like to introduce Janakiram and MSV. Uh, I think if you're in the cloud space, I'm sure you would have heard of him. And not like to take much more time because we already have probably extended about 15 minutes. I mean, we are about 15 minutes late. I'd like to invite Janki on the stage, please. Can I have some claps, please? Yeah, thank you.
Thanks. Am I audible? Very good morning, and thanks for the introduction, Srikanth. It's my pleasure to be here at the very first Cloud Connect in India. So before I get started, let me take a quick poll. How many of you are developers here? Quite a few. How many of you are familiar with platform as a service, used one of the PaaS offerings? Okay, quite a few. Okay, so this session is primarily about understanding the current landscape, who are the players, what are their strengths and weaknesses, and ultimately, if you are in the phase of choosing the right PaaS, the objective of this session is to give you the complete overview and also help you make an informed decision of choosing the right PaaS. So let me get started. Actually, the alignment is slightly different from what I have in my machine. The resolution is slightly different, but I hope it's okay. So what I'm going to cover is what exactly is platform as a service, what's the current landscape, and then we'll take a look at the big picture of platform as a service, and take a look at the feature comparison. So that's what is going to be the agenda. Before I even get into platform as a service, let me spend a little bit of time explaining the kind of the breed of applications that are being developed today and what really powers them. Interestingly, based on my experience and based on what we really see today in the industry, the applications that are being developed can be classified into three different categories. The first kind of applications that are very popular are the consumer web applications. So consumer web apps are typically the e-commerce portals and various other line of business applications, and anything that has to do with the end user and the consumer is the consumer web app category. Majority of the applications that are being developed today, the startups are investing, the VCs are funding, there is a lot of excitement, there is a lot of development around consumer web apps. That is one breed of applications. The second breed of applications is obviously around mobile. There is a lot of excitement thanks to app stores, thanks to the innovation that is coming around monetizing of mobile applications. There is a huge demand around generating mobile applications and make them available across a variety of app stores and marketplaces. So the investment and the focus around application development is primarily towards mobility. And today, if you randomly speak to any startup, anyone who is building apps, you would see that they are actually building a mobile app, which is a great sign. So it's the second breed of applications. The third one is, of course, the social applications, right? Applications which are not standalone, but primarily live in the context of Facebooks, Twitters, LinkedIn's, YouTubes, and so on. So these applications are going to be designed for viral, are going to be shared across multiple users of social networks, and they generate humongous amounts of data and contribute to the big data paradigm. So to summarize, there are three applications, right? The consumer web apps, the .coms, the e-commerce kind of applications, the mobile applications which primarily live in devices, the social applications that live in the context of social network and social media. But irrespective of these breed of applications, what really powers these applications is common. It doesn't matter whether you are developing a mobile app or a social app or a consumer web app. Ultimately, the stack that actually powers them is going to be the same. You can't think of building an application without these core building blocks. You can't think of an application without compute, which translates to servers, number of CPUs, memory, storage, and so on. Then you need external storage for better throughput, for massive durability, reliability, and scalability. Today, it's highly impossible to design a scalable application without factoring in storage into it. That's the reason why you see a lot of focus by providers on storage. So earlier storage was all about one hard disk that is going to be attached to your server or the storage that the host provides. But today storage is a building block by itself, and it is going to be external to the core compute. So that's the second building block. The third building block is, of course, networking. You need to have a very basic firewall, a very basic load balancer, a very basic topology that connects multiple components of your application. So you need networking. And finally, any meaningful application needs durable data behind the scenes, and that's where you have database. This database could be a traditional RDBMS or could be the contemporary NoSQL, it doesn't matter. But these are the 4 essential building blocks of any application. Now, that's not all. To effectively interact with these building blocks, you need to have application services. These are the APIs. These are the abstractions that give you a productive way of talking to the underlying building blocks. Similarly, you need management services for provisioning, for discovery, for administration, for user management. So various other operations-driven tasks are going through the management services block. So at a high level, what powers an app are these blocks. And on top of this, the application is going to consume and become available to the end user. But as a developer, as someone who is looking at PaaS or deploying code, it goes much beyond that. So now this is the highest level of abstraction. If we go one level below, you'd actually see that the application requires an operating system. The very fundamental choice starts from, am I going with Linux or Microsoft Windows? So operating system is very critical. On top of that, you need to finalize your core language, runtime, and framework. This is where you'll have common language runtime, C# and the .NET SDK, or the JDK, JVM, and structs as a framework. So basically, this is where you will have your language, framework, and runtime choice. And then you need a very reliable database server in the form of MySQL, MS SQL, PostgreSQL, one of those. And then you need a messaging server. This is a new entrant into the stack, which is becoming very mandatory, very important. When I say messaging, I don't really mean email messaging. This is an asynchronous message-oriented middleware that's going to be made available for making components talk to each other asynchronously. So you need a messaging server to achieve the scale and the modularity across your components. And of course, you finally need a web server that's going to be a container for your web apps. So this is going to be the detailed building blocks of your application. Now, what exactly is platform as a service? Essentially, PaaS is an abstraction of all these layers. Now, without you worrying about setting them up, configuring them, managing them, maintaining them, imagine someone is giving you a black box where you're only going to deal with the runtime and the platform requirements. For example, I might choose to develop the next generation e-commerce application on an inexpensive Lenovo laptop, but I might want to run that piece of code which is thoroughly tested on Amazon's infrastructure or Google's infrastructure or Microsoft's infrastructure. So there, I don't ask them, do you give me x86 or do you give me some other processor? Do you run Windows Server 2008 SP2 with other patches, or do you run Ubuntu or CentOS? I don't really worry about it. All I want from the provider is essentially a common denominator for my code to run. So my only question to a platform provider is, do you support Python, Perl, or PHP, or .NET, or Java? And can I port my Sinatra application, or Ruby on Rails, or an MVC framework? And if they say yes, I'm just going to just copy my code and deploy my code, which is going to be powered by the platform, which is supported by the Microsofts, Googles of the world. So essentially, PaaS comprises of these core elements that the developers are going to deal with, but not going to handle the management part of it. So ultimately, your application sits at the topmost level and deals with all of them without any overhead or the plumbing that's required. So just to translate that further, a typical Microsoft PaaS would look like this. It's powered by Windows Server, it runs .NET, IIS, SQL Server, MSMQ, and your application deals with a Windows or a Microsoft PaaS. If you come from a Java environment, this is how a typical Java PaaS stack would look like. You get Tomcat container, you get RabbitMQ, you get a MySQL or a PostgreSQL, and these are two different PaaS implementations that you can visualize. This is how Windows Azure would actually look like, and this is how Beanstalk or any other Java-based PaaS would look like. So essentially, this is the real implementation of how PaaS will translate into. So currently, the PaaS landscape is highly fragmented. It's actually cluttered. and I was talking to one of my ex-colleagues and a friend, and he says he managed to identify about 70 PaaS players in the market. And this is just a tip of the iceberg, and I have only put the most popular, most talked about PaaS players. But even then, this slide is cluttered, and all of them are very active, highly innovative, and almost updating their stack on a day-to-day basis. So with this clutter, how do you go about choosing the right PaaS? And I have Krishnan here, who thoroughly inspired me to look at PaaS, and having worked for Microsoft in the Windows Azure environment, had access to that in the incubation days. I was very passionate about PaaS from the day one. And after reading a lot about PaaS, particularly coming from Krishnan, I got fascinated by this, and I went into the details and the underpinnings of PaaS, and it looks very intimidating, because today the PaaS world is claiming to support everything under the sky. Every player is claiming to support everything, and it's very, very difficult for business decision makers to really choose one and say that's their PaaS that they're going with. So what I'm going to do now is to take 4 popular PaaS stacks that are out in the market, and then analyze their strengths and weaknesses. In half an hour, this is a futile attempt. I cannot really do justice to it, because each of those stacks require a very thorough, detailed analysis, but my objective is to give you a very brief understanding of their strengths and weaknesses and the big picture. So having, looking at the current landscape, let's take a look at the big picture of some of the popular stacks. This is one of my favorite, Windows Azure. I come from this background. So I also translated them to the building blocks that we have been discussing. So you would see compute, you would see storage, you would see application and management services, databases. So that's the lowest common denominator across any PaaS that you can deal with. So Windows Azure is very mature. It's primarily designed for enterprise. It has come up with a fairly prescriptive architecture, which works for and also against the stack. But I don't have enough time to drill down into this, but as you notice, this stack is almost complete, as in it has the compute, the storage, the database, the networking, and various application services in terms of caching, service bus, access control, and they also support networking. Though it is a PaaS stack, they let you directly open up a pipe to the data center and talk to the virtual private network. So that's the Windows Azure big picture. Now if you look at the strengths, if you are in the .NET world, it's a no-brainer for you to look at Windows Azure, but that's quickly changing with other competitors for Windows Azure coming up in the form of Uhuru Software and Iron Foundry. But this is still a valid statement, because if you are in the .NET world, if you are a Microsoft customer, your logical choice could be Windows Azure. So Microsoft's brand and the marketing muscle is heavily influencing its customers to invest in Windows Azure. No other PaaS provider has the reach and the marketing muscle that Microsoft has. So it's actually adding to the advantage of Microsoft. Microsoft has been the early mover in this space, definitely one of the very early PaaS stacks to come out in the market after Google App Engine. And though they haven't been able to move in a very agile form, they still made a mark as an early mover, and Windows Azure really sits in one of the early top PaaS stacks, and it is complete. It has all the key elements that you require to go live with a very mission critical and very scalable application. Surprisingly, though Microsoft has been very slow in iterating the features, they are rapidly evolving. Actually, June 7th, there is an event in Silicon Valley where Microsoft is going to announce a bunch of new features to Windows Azure. There's a lot of speculation that Windows Azure is going to add a lot many more features, appealing to both IT infrastructure administrators and also for Microsoft developers. So surprisingly, unlike other products, Microsoft is very rapidly evolving and adding the feature set to Windows Azure, which is good. And their traditional strength of Visual Studio and the development platform holds good for Windows Azure. Great integration with Visual Studio, one-click deployment. They got that story pretty well, pretty right, and that's definitely one of their strengths. When it comes to weaknesses, it's perceived as a .NET-only platform. Though Windows Azure is claiming to be polyglot, Polyglot is a capability to speak multiple languages. So today the PaaS implementations are almost polyglot. Every stack that you can name is claiming to support a variety of languages, and Windows Azure is not an exception. If you go to windowsazure.com, you would see Node.js, you would see PHP, you would see Java, and of course .NET. But the market perception is that it is only a .NET PaaS, which is true to a large extent, though technically you can run a variety of platforms and literally anything, all the way from Perl to Python to even COBOL. They are not persistent, as in you cannot take traditional legacy workloads and run it off Windows Azure, because Windows Azure is highly prescriptive. One of the biggest feedback from customers and anyone who is migrating an application to Windows Azure is, unlike other Microsoft patterns, Windows Azure is highly prescriptive. They precisely tell you what has to be done, and architects feel little constrained, little limited by the capabilities that Windows Azure offers. So those limitations hurt some of the migration strategies and some of the use cases, which makes it extremely difficult to run on Windows Azure. Again, coming back to interoperability, though Microsoft has been investing in the open source Eclipse ecosystem, bringing in PHP and so on, it is still incomplete. If you take a LAMP stack that you typically run on Rackspace or AWS, with the freedom that you have with Zend and Memcached and a variety of scalable techniques, unfortunately it's hard to emulate them on Windows Azure. So it somewhat appeals as an incomplete stack when it comes to non-Microsoft technologies. While it is extremely transparent, it also makes it complex because of lack of abstraction. It is not like a very easy to deal with black box. You need to know the nitty-gritties, the nuts and bolts, and as a developer, you got to do a little bit of plumbing, which Microsoft could have avoided with the right set of abstraction, particularly with the contemporary PaaS players. This is one of the strengths of them, and Microsoft has to do something about abstracting out Windows Azure much more clearly. So next comes in Google App Engine, one of my very early favorite PaaS players, but it's kind of unfortunate that Google hasn't been doing much to really push this. And in fact, I wrote an article a couple of months ago, which is called Google App Engine, Is It Losing the Steam? And it is unfortunately the sad fact where App Engine is losing the steam. They could have been the pioneers, they could have been one of the largest PaaS players in the space of Python and Java, but something didn't happen the right way, and Google never got the developers on their side when it comes to App Engine. But it does have some advantage. It's an early mover, one of the very first Python and Java PaaS to go live, the only first polyglot PaaS. In fact, before Stack started claiming support for multiple languages, App Engine had it in the form of Python and Java. Obviously, it's very well integrated with Google Apps. That's one of the biggest draws for Google. So every time they push Google Apps and they migrate a Lotus Notes or an Exchange-based application, the code moves to Google App Engine. So Google Apps and Google App Engine go hand in glove, which is working to an advantage of Google. Great for consumer web apps, but if you want to take any other use case, very, very limited, very constraining. And even Java developers complain quite a lot that it's not real Java. It cannot run a variety of libraries and doesn't support the standard techniques of running scalable Java apps. But its integration with Eclipse started very early. The SDKs are mature, but very slow evolution. It's been in beta for a long time. I think it is still beta. So very slowly evolving. Google has been almost dropping the ball when it comes to iterating the features. Pricing has created a lot of friction in the developer community, and that forced them to move away from Google App Engine to Heroku and commodity PaaS. Google actually hurt themselves when they announced the pricing model last year. It didn't do any good. Instead, it drove away customers to Herokus of the world. Lack of support for line of business applications. This is a very, very big drawback. You can't run a non-consumer web app within App Engine. It is meant only for consumer-facing typical web applications. Anything other than that is extremely hard to emulate. Too prescriptive. Google tells you more of what you cannot do rather than what you can do with the stack. So you need to really know a lot of things that you're not supposed to do before you target this platform, and that's not that's not really appealing. This is slightly old. Last week, Google has announced the pricing for Google SQL, which is their consistent relational database service. So this is Void, which is just added, and now they have gone live with pricing as well. Coming to Beanstalk, I have a lot of affinity to this stack because I was in Amazon when this got launched, and I got a chance to work on this at a very early stage. Amazon Beanstalk is more like an illusion. I call it an illusion because it is a very thin layer that may or may not exist, and Amazon Beanstalk doesn't bring anything new for the Amazon customers. Anything that you can do with Beanstalk can be done directly. But Amazon's key objective with Beanstalk is to have a developer connect, because Amazon is perceived as an IT pro operations infrastructure stack, and developers are not comfortable dealing with elastic load balancers, elastic IPs, firewalls, and the nuts and bolts. And that's the reason why engine yards and Herokus that got built on top of Amazon took off big time and became very developer friendly. So to compete with those PaaS, which are actually running on AWS, Amazon had to do something. So they came out with Beanstalk as a nice abstraction. It's more like a topping on the cake, while the cake is still AWS. So this topping gives developers an illusion that they're dealing with PaaS. But behind the scenes, they actually deal with Amazon's EC2 and DynamoDB and RDS, and you still need to know quite a bit of Amazon Web Services if you're dealing with Beanstalk. So abstraction of proven AWS technologies, no doubt, if you're using Beanstalk, you are powered by the proven AWS, the best thing. Great control of the environment. This works for and against Amazon, because if there is a memory leak of one of your components running in a Tomcat container, nothing prevents you from taking the control over as root and really looking at the lowest possible diagnostic instrumentation data and figuring out what's going on. So you have great control. You can go to any level of stack and really take control of it. Tight integration with AWS services. They could have done it better, but obviously the jar files that you upload and everything sits in S3, and they give you very easy way of consuming AWS services within Beanstalk. Did a fairly good job of integrating with Eclipse and also now with Visual Studio.NET. It is polyglot, and incrementally Amazon has been adding support, which is a great sign. It started with Java initially, only for web apps. It doesn't support J2E, but started with Java. Then last month they added support for PHP, and the best thing is they support JIT-based continuous integration, fantastic thing. And last week they have gone live with .NET, which is giving a tough competition to Azure. So now you can host ASP.NET applications on Beanstalk. Along with it, they also announced that SQL Server support for RDS. So that's going to become a tough competition for Microsoft when it comes to the .NET Cloud. So it's been beta for the last 1 year and more actually. It's available only in select regions. It was available only in US East, and now they extended that to Tokyo, Asia Pacific Northeast. Lacks support for J2E. Your container choice is limited only to Tomcat. So if you come from a Jetty background or you want to run JBoss, you don't have the container support. And it's a myth that Beanstalk will totally abstract and make you completely oblivious to the underlying building blocks. This is actually, you need to know quite a bit of AWS technologies to exploit Beanstalk. So you can't get away from understanding how AWS functions. So Beanstalk is just a thin layer that sits on top of existing AWS infrastructure. Now I want to talk about one of my recent found love, which is Cloud Foundry. VMware announced this exactly a year ago. Recently, Cloud Foundry celebrated its first year anniversary. And VMware is doing something which is very, very smart. While the deep-pocketed companies are investing in their own PaaS implementations and going about hiring the best talent in the world to architect Windows, Azure's, Google App Engines of the world, VMware's philosophy is simple. They want to turn every hoster to be a PaaS player. So that way they don't just compete with Microsoft's and Google's, but they can potentially compete with anyone who is going to enter the market in the future, and they want to truly democratize PaaS. So how do they do that? They don't want to get into the game of creating a .NET PaaS or a Python PaaS or a Perl PaaS. Instead, they invested in creating what is called as a Meta PaaS. The marketing term for Meta PaaS, according to VMware, is called Open PaaS. So they actually give you a framework. You can inject any flavor of runtime language into the framework, and you can go live as a PaaS player. Very exciting. Technically, it is very fascinating to look at the underpinnings of Cloud Foundry. Within first 1 year, they created a huge momentum. ActiveState came out with Staccato. PHP Fog turned into App Fog with the support of Cloud Fog, and today they have gone live in public beta. Couple of ex-Microsoft employees stepped out of Microsoft and embraced Cloud Foundry to announce first ever .NET PaaS in the form of Iron Foundry and Uhuru Cloud. So huge momentum, and many other partners are stepping up their support, and one of the most comprehensive stacks that anyone can download, which is on GitHub. So you can actually go download the source code, compile, and go live with your own PaaS, or you can set up your own PaaS running on Rackspace or Amazon. Same thing with Red Hat's OpenShift. OpenShift and Cloud Foundry are almost symmetrical. They are so identical that their philosophy is the same. Be the open source PaaS, and recently, a couple of weeks ago, Red Hat has opened up the source code in the form of OpenShift Origin, and they claim to support the JBoss flavor as the first enterprise Java PaaS. Both philosophies of Cloud Foundry and Red Hat are exactly the same. Be the open source PaaS world, democratize, commoditize PaaS, and also play in the space of private PaaS, which is picking up a lot of momentum. So enterprises don't want to deal with the underpinnings of infrastructure, so they want to give a stable dev, test, staging, production environments to their internal development teams, and they want a PaaS. So VMware and Red Hat are locked in this battle of supporting that consistent PaaS platform all the way from their internal private cloud till the public cloud. So it's going to be an interesting battle to watch for. So that's Red Hat OpenShift. I know this slide is not visible to you, but what I attempted is I took some of the common capabilities like the number of languages, tools, NoSQL support, RDBMS, asynchronous messaging, federated identity, content delivery network, caching, PubSub and notifications, and finally monitoring. And I kind of tried tabulating this entire thing, and as you notice, it's very hard to pinpoint to one. Most of them are supporting, but personally my vote in terms of completeness goes to Windows Azure because it's enterprise PaaS. Then comes in Beanstalk. Again, it's an illusion. Actually, I should call it Amazon, not just Beanstalk, but it is extremely complete. And then comes in App Engine in the third place when it comes to completeness. So I'm going to share these slides on SlideShare, and you can take a closer look at it. And interestingly, this is changing almost on a weekly basis. I'm going to update that. So I'm spot on time. So to summarize, the PaaS landscape is changing rapidly. The last 6 months of PaaS has been phenomenal. I think more than any other delivery model, unlike infrastructure or software as a service, PaaS is the biggest fast-changing cloud service delivery model out there. Windows Azure is definitely the choice of .NET. If you are in the business of .NET and looking at cloud, take a look at Windows Azure. If you are comfortable dealing with Amazon but want to empower your developers to abstract out Amazon, Beanstalk is for you. Be cautious when you are investing in App Engine. There is not enough confidence in the community and the customers to invest in App Engine, so be very clear what you want out of App Engine. Do keep an eye on Cloud Foundry and OpenShift very early, but it's going to change the complete game in the next 2 quarters. So that brings us towards the end of the session. That's my email ID. Questions? CA, honestly, I'm not sure if there is any PaaS offering from CA. Not that I am aware of. Maybe they have something, but I'm not familiar with CA's PaaS offering.
Mics there, please. Yeah.
Hi, this is Gaurav here. You talked about the prescriptive nature in Windows Azure and Google App Engine, that they're quite prescriptive. How do open offerings or Amazon Beanstalk stand on this particular perspective. And essentially, I think it's a thin line with the features that especially Windows Azure offers. It's a give and take kind of thing. They are prescriptive, but then that allows them to provide so much good features also.
Right. So so there is a thin line between control and flexibility, right? So what I love about Amazon is it's best of both worlds. I'm a developer. I don't care about the choice. I don't want to deal with the nuts and bolts. I look at the highest level of abstraction, which is Beanstalk, and I use Eclipse. I write code. I push a button. I go live. But nothing prevents me from ripping up the Beanstalk layer, going deep into the EBS volume, looking at the logs, fine-tuning, changing the JVM memory settings, or updating a legacy DLLs or a jar file. So basically, I go deep into the stack and do what I want to do. And I can emulate what is running on my data center on-premise pretty much on AWS. So that's the reason why it's best of both worlds. But when it comes to Microsoft, once you deploy code in a web role or a worker role, and once you have gone live, it's a nightmare to pinpoint to what is going on and what is going wrong. So the analogy that I give is deploying your app on a PaaS is like flying an unmanned aircraft. There is no pilot, you can't communicate, no one can tell you what latitude, longitude they are, but the flight is midway on the air, and the only communication is your air traffic control dashboard, and whatever data is sent, you need to consume that. You don't have a human to talk to. That is the problem with App Engine and Windows Azure. On Amazon, you take the pilot role, right? You log on to your EC2 instance, you become the root, and you are in the cockpit. You have all the knobs, all the buttons, you turn them around, you get the best performance, and then you put it in an autopilot mode and come back. That's the beauty of Elastic Beanstalk versus Azure and App Engine, which is an unmanned aircraft, which is on the fly, and you only look at metrics that they send you. So that's a control versus flexibility part of it, right? I'm hanging around here for offline questions, so I will let Krish take over and walk you through the next iteration of PaaS. Very interesting talk. So I will let him come over and take it forward.
Thanks.
Thank you.
Thanks, sir, for that wonderful talk. We'd like to offer you a small token of our appreciation.